What we're supposed to do first? We're supposed to mark the changes of waveform A and waveform B, like always. I have another transition from high to low at this time, and at this time I have transitioned from low to high, and I have transitioned from high to low. I'm finished with waveform A. Next, I'm supposed to do the same thing for waveform B. But please notice that we have already marked, because this transition from low to high is going to occur at the same time when B waveform is going to go from low to high, and this transition from high to low occurs at the same time when A waveform goes from low to high. Okay, so we are okay also with waveform B. Next, please realize that this is level 1 and this is logic 0. 1, 0, 1, 0 for the NOR gate will give me 0 at the output. That's why I'm going to write 0 over here. Next, I have logic 0 and logic 0. When both inputs are receiving 0, output is going to be high. That's why I'm going to write 1 over here. I have 1, 1. 1 and 1 gives me 0. That's why I'm going to write 0 here. And I have 0, 1, 0, 1 or 1, 0 gives me 0. And I have 1, 0, 1, 0 or 0, 1 gives me 0. Okay, you have to remember that anytime we talk about NOR gate, any 1 at the input will give me 0 at the output. Okay, and let's take a look at this column. We have logic 0 and logic 0. When both inputs are having zeros, output is going to be high. Now we can draw the output waveform. Okay, again I have 0, 0, 0, 0, and I have 1. Okay, this is my output waveform for these two input waveforms, of course applied to the NOR gate. And I can say that this is the solution to my problem.